Hey math fans, we're on section 2.3.1. Let's get started. What is a sequence? A sequence is a list of things, usually numbers, that are in order. Here I have an example where the first term is 3, the second term is 5, the third term is 7, and the fourth term is 9, and then you see the little ... And that means it's going to continue on forever, an infinite number of terms. There's infinite or finite sequences. When it goes on forever, it's called an infinite sequence. Otherwise, it's called a finite sequence. Here are some examples. The notation for a sequence uses the set notation symbol or the set brackets, or also called braces. They're the curly brackets that are located right next to the P on your keyboard, but you're going to have to hit Shift to get the curly brackets. A sequence usually has a rule, which is a way to find the value of each term. We're going to use the example 3, 5, 7, 9, continued. Remember the function machine? Here's an example. If x is equal to 1, we substitute the value of 1 in for x here and here. As you can see, there they are. And as you can see, 2 times 1 is 2, plus 1 is 3. So you would say f of 1 is equal to 3, or in other words, the value of y when x is equal to 1 is equal to 3. For a sequence, we're going to use the letter A instead of the letter F. And then this subscript is going to stand for which term. Which term are we looking for? Are we looking for the first term, the second term? So A sub 1 would be the first term. A sub 2 would be the second term. A sub 3 would be the third term. So the notation's a little bit different, but it behaves the same way as a function. We're putting a value in for the term. We're getting a value out that will be a part of that sequence. I've created a table here where the first term, and as you can see it in the graph here, the first term, A sub 1, is 3. The second term is 5. A sub 2 is 5. Now, notice you should be getting the same value if you subtract the third term from the second. 7 minus 5 is 2, and that's the same as 5 minus 3. It doesn't matter which two terms you use, but they do have to be right next to each other, and you always go with the higher term first. So you could do A sub 4 minus A sub 3, or A sub 3 minus A sub 2. And I just did the second term minus the first term. And that gives you what is called the common difference. And that will be the variable D. There are two different formats to find the nth term. And again, n could be any number. This right here always stands for, I want you to write this down, previous. This is your previous term. And this is the nth term. This is the term you're looking for, okay? The nth term. Now, the explicit formula always uses the first term, and it will take you to whatever term you would like. So if I wanted the 7th term, as long as I know the first term, I could always get that term by just substituting whatever those numbers are. If I knew the common difference, if I know which term I'm looking for, if I know the first term, I can always find the nth term. Example 1, what is the fourth term of the sequence given by the formula A sub n is equal to A sub n minus 1 plus 5? Because we are using the previous term, this is going to be recursive. Recursive means that we're using the previous term to try and figure out what the nth term is. So since the first term is 2, I've made a table here, And I put the 2 right there. So my first term is 2. I don't know what my second term is. I don't know what my third term is. And this is really what I'm looking for. What is the fourth term? Now, the recursive only allows you to go from the previous term to the term you're looking for. So I can't use the third term. I can't use the second term, but I'm going to use this. Basically, according to this, if I want this term, if I want the second term, I look to the first term and add 5. So my second term will be 7. And then I'm going to add 5 again. My third term is going to be 12. So A sub 4, or in other words, the fourth term would be 17. Find the missing terms in the sequence using recursion. Again, I would make a table. With the table, it's pretty easy to see the common difference. 13 minus 8 is 5. So again, this is going to be a common difference of 5. I'm adding 5 every time. Again, to find that common difference, you just subtract a term minus the previous term. So what would the next one be? Well, you'd add 5 to it. So it'd be 28. You'd add 5 to it. It would be 33. You'd add 5 to it. It would be 38. So the 5th, 6th, 7th terms are right there.